welcome to True Projects. In this video, we are going to explain about the project, which is credit card fraud detection using state-of-the-art ML and DL front-end. Introduction. In recent years, the widespread adoption of credit cards has brought about a concerning increase in the potential of credit card misuse and fraudulent activities. As the usage of credit card has expanded, so sophistication of credit card frauds resulting in substantial financial losses for both individual cardholders and financial institutions has increased. The project addresses this issue for mitigating the financial losses incurred due to credit card fraud. Additionally, it seeks to bolster the overall security and trustworthiness of financial transactions, providing cardholders with a sense of confidence in their financial dealings. A comprehensive approach by integrating both conventional machine learning and advanced deep learning techniques are adopted. By leveraging these state-of-the-art methods, the project aims to significantly enhance the accuracy and efficiency of credit card fraud detection, ultimately contributing to a safer and more secure financial landscape for all stakeholders involved. Objective of the project. The primary goal of the project is to develop a robust and effective credit card fraud detection system. To achieve this goal, the project leverages a combination of machine learning and deep learning algorithms, including SVM, random forest, KNN, decision tree, logistic regression, voting classifier, XGBoost, MLP, baseline BL, CNN with LSTM, CNN and balanced CNN. These algorithms play a vital role in enhancing fraud detection by analyzing transaction data for unusual patterns and adapting to evolving fraud tactics. The ultimate objective is to achieve a high level of accuracy and efficiency in identifying fraudulent credit card transactions. By leveraging these diverse algorithms, the project aims to provide a comprehensive solution that minimizes financial losses for both cardholders and financial companies while improving overall transaction security and trustworthiness. For implementing the project, we need hardware and software requirements. Coming to hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed. Coming to software, we need Anaconda 3 and Visual Studio Community version. We have designed few modules in the flow of work to implement the project. The first one is importing the libraries. In this module, we import essential packages and libraries, and they are NumPy for numerical and mathematical operations, Pandas for data manipulation, Matplotlib and Seaborn for data visualization, TensorFlow is for deep learning. Exploring the dataset. This step involves a thorough examination of credit card transaction dataset. We analyze its structure, content, and statistics to gain an understanding of the data. Visualization using data using Seaborn and Matplotlib. In this module, we use Seaborn and Matplotlib libraries to create visual representations which are plots and charts of the dataset. It helps in identifying patterns, trends, and anomalies in the data. Feature selection. This step involves selecting the most relevant features for predictive model. Feature selection helps in improving model efficiency and accuracy. Selecting the X and Y for imbalanced and balanced data. We define the input feature as X and the target variable as Y separately for both balanced and imbalanced datasets. Feature selection algorithm using RFE with logistic regression. We use recursive feature elimination, which is RFE, with logistic regression as an algorithm to select the most important features for modeling. Splitting the data into train and test. This module divides data into training set and testing set. Training set is for training the model and testing set is for testing the performance. Building the model. In this stage, we build predictive models using both machine learning and deep learning techniques. Machine learning modeling. We implement various ML algorithms and they are support vector machine. It is supervised machine learning algorithm used for classification and regression tasks. It finds a hyperplane that best separates data points into different classes. It is employed for its effectiveness in classifying credit card transactions as fraudulent or legitimate. Random forest. It is an ensemble learning method that combines multiple decision trees to improve classification and regression tasks. It is used to enhance the accuracy of fraud detection by aggregating predictions from multiple decision trees. KNN, which is K nearest neighbor. It is simple and intuitive algorithm for classification and regression tasks. It classifies data points based on the majority class among their k nearest neighbor. It is utilized for its simplicity and effectiveness in identifying patterns in credit card transactions. Decision tree. It is a tree-like model that makes decisions by splitting data into branches based on feature values. It is used for their interpretability and ability to uncover rules governing fraudulent transactions. Logistic regression. It is a statistical method for binary classification that models the probability of an event occurring. Logistic regression is employed for its simplicity and interpretability in predicting the likelihood of credit card fraud. Voting classifier. It is an ensemble method that combines the predictions of multiple base classifiers to make predictions. The voting classifier aggregates the output of support vector classifier, random forest, decision tree to boast overall prediction accuracy. XGBoost. It is a gradient boosting algorithm known for its high performance and efficiency in handling structured data. It is chosen for its ability to handle imbalanced datasets and improve fraud detection accuracy. MLP. It is a type of artificial neural network with multiple layers of interconnected nodes used for various machine learning tasks. MLP is employed to capture complex relationships in credit card transaction data and improve prediction accuracy. Deep learning models. Here we develop deep learning models, and they are: the first one is Baseline BL. Baseline BL refers to a simple basic model used as a reference point for comparison with more complex models. It serves as a benchmark for evaluating the performance of more advanced models in the project. CNN with LSTM. CNN is a deep learning architecture primarily used for image analysis, while CNN with LSTM combines CNN with long short-term memory for sequential data analysis. Its architectures are adapted for credit card transaction data to capture spatial and sequential patterns, improving fraud detection. CNN. It is a deep learning architecture designed for processing and analyzing grid-like data such as images and sequences by using convolutional layers to extract features. It is applied to credit card transaction data to automatically learn relevant features and patterns, improving the model's ability to detect fraudulent transactions based on the transaction's attributes and sequences. Balanced CNN. Balanced CNN refers to a CNN architecture specifically designed to address class imbalance in classification tasks. Balanced CNN is utilized to enhance fraud detection by mitigating the effects of imbalanced data. Coming to training the model. This module involves the actual training of the models using the training dataset. The models learn from the data to make predictions. Flask framework with SQLite for sign up and sign in. We implement a web-based front end used for Flask. A Python web framework is developed. An SQLite database is used for user registration and login functionalities. User gives input. User provides input data, typically representing a credit card transaction for prediction. The given input is pre-processed with trained model is used for predicting the performance. In this, the given input will be pre-processed and then it will be used for training the model. Final outcome is displayed. The project displays the final outcome, which is the prediction result. User can see whether the input transaction is classified as fraudulent or legitimate. This is the comparison graph of the project, where x-axis represents the accuracy score and y-axis represents the algorithm names. Among all the algorithms, the voting classifier performs well, so we are using voting classifier for predicting in the web interface. For execution, we need to open the code folder of the project. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the notebook file. This is a Jupyter notebook file which contains a combination of code graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the model file. This file contains the algorithm information which will be loaded into the project code during runtime. This is the sign-up file. This is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. Now we'll copy this path. And now we will open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on enter. So the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file using the command python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless configured differently. And this is the localhost and this is the port number. Now we will copy this link and paste it in any browser. I prefer Google Chrome, so I will paste it in that. So here we will paste the link and then click on enter. The homepage of the project is displayed in the browser, and this web page is built by using the Flask framework. Now we will click on sign up. Here we need to fill all these registration details if we are registering newly. I have already registered, so I'll directly click on sign in. I need to provide my credentials, which are username and the password. Now I will click on register. So this has redirected to the homepage of the project, where we need to fill all these parameters and the amount and then click on predict. By that we will get whether the credit card transaction is fraudulent or correct. Now we will fill all these details. I filled all these parameters and the amount. Now I will click on predict. So it is predicted that based on the PCA feature values, this transaction is fraudulent, which means the credit card is fraudulent. Now we will give other inputs and see what will be predicted. I filled other person transaction details and the amount. Now I will click on predict. So it is predicted that based on the PCA feature values, the transaction is non-fraudulent. Now we will give other inputs and see what will be predicted. I entered all the financial transaction details of the credit card of the person. Now we will click on predict. Based on the PCA feature values, the transaction is non-fraudulent. In this way, we can give credit card transaction details in the input as the parameters. Then we will be getting the prediction whether the transaction is fraudulent or not. Now we will sign out. This project has successfully addressed this issue of credit card fraud by developing a powerful fraud detection system. Through the utilization of a diverse set of machine learning and deep learning algorithms, it has achieved a high level of accuracy in identifying fraudulent transactions. Beyond the technical aspects, the project significantly contributes to enhancing financial security. Cardholders and financial institutions alike benefit from reduced financial losses and increased trust in the security of credit card transactions. Recognizing the ever-evolving nature of fraud tactics, the project highlights the need for ongoing innovation in fraud detection. Future endeavors can focus on staying ahead of emerging threats and further improving the system's effectiveness. The culmination of this project is an impactful solution that not only protects financial interests but also fosters confidence in the safety of financial transactions. It emphasizes the importance of harnessing technology to address critical challenges in the financial industry.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Projects YouTube channel and subscribe.